Welcome to NASA Launchpad. I'm your host, Audrey Staples. Eclipses. Yeah, I know we're always talking about NASA Eclipse here on Launchpad, but those are the short video clips you're watching. And no, we're not talking about the book in that vampire series. Come on, focus here. We're talking about one of the most spectacular natural phenomena you can witness here on Earth, or anywhere else in the solar system for that matter. When a solar eclipse occurs, light from the sun is blocked. Actually, that does sound like a good premise for a vampire story. Let me go write that down. In the meantime, here's an expert on eclipses, Fred Espinette, also known as Mr. Eclipse, from NASA Goddard Space Flight Center, to really help us understand these incredible astronomical events. And just keep in mind, these animations you're about to see are not to scale.
A total eclipse of the sun is one of the most awe-inspiring sights in all of nature, and it's all made possible due to the unique geometry in the distances and sizes of the sun and moon as seen from the Earth. As we all know, the moon orbits the Earth and the Earth orbits the sun, and celestial mechanics allows us to calculate these orbits with great precision. When the moon passes between the Earth and the sun, we say that the moon is in the new phase. An eclipse of the sun can only occur when the moon is new. However, not all new moons produce a solar eclipse. The moon's orbit around the Earth is tilted about 5 degrees to the plane of the Earth's orbit around the sun. As a result, the moon spends most of its time either above or below the Earth's orbital plane. The moon passes through the plane only twice during each of its orbits. If the moon also happens to be in a new moon phase when it crosses Earth's orbital plane, then a solar eclipse will occur. Most eclipses are partial because new moon takes place just before or after the moon crosses the orbital plane. But if the timing is right, a total eclipse of the sun occurs just as the center of the moon passes directly in front of the center of the sun. The path that the moon shadow makes over the Earth during a total eclipse is called the path of totality. To see a total eclipse, you must be in the path of totality. As a total solar eclipse begins, a ghostly silhouette looms into view, framed by a white glow that creates a halo around the darkened sun. In the final seconds, the sun's remaining rays shine through deep valleys along the edge of the moon. At the same time, the sun's corona appears, surrounded by the moon's black disk. Before the last bead of sunlight vanishes, the effect resembles a cosmic diamond ring. Suddenly, totality. The bright sun is gone. A black disk surrounded by a pale halo now stands in its place. The sun's corona is the most stunning, most beautiful, and most unexpected feature of a total eclipse. As the outermost layer of the sun's atmosphere, the corona is extremely hot with a temperature of 2 million degrees Celsius. The moons of other planets in our solar system produce eclipses, but none of them have the perfect size fit that total eclipses have from Earth. In some cases, the moons have angular sizes that are much larger than the sun. In other cases, the moons are much too small and too far away to cover the sun. We call this kind of an event a transit. Our NASA Mars rovers have both photographed Martian moons Phobos and Deimos as they transited the sun. Pretty cool.
All right, I've got to be honest, I don't get it. How can the moon, which is about 1/6 the size of Earth, cover up the sun, which is 400 times larger in diameter than the moon?
To compare the relative sizes of the Earth, moon, and sun, we'll use this basketball and this tennis ball. Let's call this basketball Earth and this tennis ball the moon. These are the relative sizes of the Earth and moon to each other. So what do you think we could use to represent the size of the sun? A small car? Think bigger. The sun would be 90 feet in diameter, about the size of this office building. So how is it that this tennis ball-sized moon can block this building-sized sun? The answer is angular size. Angular size is the measure of an angle formed by extending imaginary lines outward from a specific point to span the width of an object. The imaginary lines form a triangle. Angles are measured in degrees. Two objects in space may appear to be the same size if their distances and diameters are proportional, and if they are viewed from the same position on Earth. The diameter of the sun is 400 times larger than the diameter of the moon. But the sun is also 400 times further away from the Earth than the moon is from our planet. If you extend imaginary lines that span these two objects to our viewpoint on Earth, you can see that two similar triangles are formed. The angles formed at the viewpoint are the same for both objects, making the angular size of these objects equal. When these bodies line up exactly, the moon appears to be the same size as the sun, creating a total solar eclipse. This fortunate coincidence is responsible for the perfect fit of the total solar eclipse, one of the most spectacular events you can possibly witness in our solar system.
Unlike, say, the Venus transit, solar eclipses can happen several times a year. In fact, in the 21st century alone, there will be 224 solar eclipses. Of these, 68 will be total eclipses. Of course, just because an eclipse will happen doesn't necessarily mean that you'll be able to see it. Due to the position of the Earth in its orbit around the Sun, only certain areas are able to see each eclipse. But don't worry, with a little research, you can find out exactly when the next solar eclipse will be blotting out the Sun in a town near you. Check out NASA's website on eclipses at eclipse.gsfc.nasa.gov/eclipse. But remember, even if there's an eclipse, you shouldn't look directly at the sun because it can seriously damage your eyes. That's it for now. Until next time, I'm Audrey Staples for NASA Launchpad. Thanks for watching.